Today we are going to start new chapter, that is aggregation and group by. In Pandas, aggregation refers to any operation that takes multiple values like a whole column and squashes them into a single summary number like a sum or average. Pandas provides a massive set of these functions. You can apply them to a single series, a column, or entire data frame. The week 5. These are 5 functions you will use 90% of the time in data analysis. First one is sum. It adds up all values. Mean calculates the average, then median finds the middle value. Min and max, these find the lowest and highest values. Then we have count. Count is the number of non-empty values. So first thing, I'm going to load the pandas as PD. Now I'm going to import the data into pandas with read underscore csv, and the file name is train.csv. and if I run this, so to get an overview of our data frame, we will use the head and data types method like store.head. Here I got the first 5 rows of our data frame, and if I want to know the data type, I can use store.dtype. Here are the columns with their data types of our data frame. Today I'm using the store data set. Now we are going to do the aggregation. First the sum, store dot sales dot sum. Here is the total of all the sales column. So one thing that you must keep in mind is that don't use the sum function on non-numerical columns because adding text doesn't make sense. If I want to get the average, I can use the main function. Here is the average of the sales column. If I want middle value of the sales column, store.sales.median. Here I got the middle value of the sales column. And if I want to find the minimum, the same method I can use sales.minimum. Here is the minimum, sales.max to get the maximum. If I want to count the values, I can use the count function. First, if I use it directly on the data frame, I will get count for all of the columns. Here I got the non-null count of all the columns. If I want to count non-null values of a specific column like sales column, I can use count function on it. I can use it with any column like state.count to count total number of status, to count total values in this column. These were the basic aggregate functions that we use most of the time. So keep these in mind: the sum, mean, median, minimum, max, and count. So keep these in handy and they will save you a lot of time while doing the aggregation. Now the statistical and distribution functions, these help us to understand the shape and spread of our data. Like we have a standard and variance functions that are used for standard deviation and variance. Mean is they tell us how spread our data is. These measure spread, they tell you how far away the data points are from average. Then we have quantile function which finds values at specific percentiles. Then we have the skew, which tells us if the data leans more to one side. We have kurtosis function which measures how peak or flat our data distribution is. Then we have unique, which count as how many unique items are in a column. These are statistical and distribution functions. Store.sales.std to get the standard of our sales column. Store.sales.variance to get the variance of our sales column. Standard deviation measures the amount of variation or dispersion in a set of values, and the variance is the average of the squared differences from the mean. It gives us an idea of how much the data points deviate from the mean. If I want to find the quantile, I can use the quantile function to find the 25% quantile. Means 25% of the data is below the 17, means 25% of the sales are below 17. Then I can use, so here I got 25 percentile, 50 percentile and 75 percentile of my sales column. If I want to get the CQ, I can use the CQ function. Here is the CQ value of the sales. CQ measures the asymmetry of the distribution. A positive CQ indicates a longer tail on the right side, while a negative CQ indicates a longer tail on the left side of the data. I can use the code function to find the curtices. Store.sales.cut. Here is the code value. I can use the store.nUnique to get the unique values of all the rows, or I can use it on a specific column like sales.nUnique to get the unique values of the sales column. We can use the function to count the unique values of any column. Like I can count on the postal code. These were the statistical and distribution functions. Now we have a very important function, which is the aggregation function. Instead of running one function at a time, you can use the agg method to run multiple calculations at once. This is extremely efficient. This is the power of Python. If I want to get the minimum, max and average of the sales column all at once, I can use the aggregate method .agg, and I can use any number of functions here as values for all of these functions without writing them one by one. Here I used all the functions. I can use as many or as little as I want. Here is minimum, max and mean of the sales column. If I want separate values for separate columns, then I can use dictionary inside the aggregate function to find the separate values for separate columns. Like, so for sales column I calculated the minimum, max and mean, and for the state I calculated the unique values. So there are 49 unique states. This is how we use a dictionary inside the aggregation function to count the separate values for separate columns with just one line of code. So now there is another very important function, that is group by. Aggregation is most powerful when combined with group by. This is exactly like a pivot table in Excel or a group by in SQL. So if I want to find the average sales value for each state, I can do it with the group by method. Here I calculated the sales minimum, maximum and mean value and grouping them by region. So that means here I am calculating minimum, maximum and mean values region by region. I can group by state. Here I'm calculating minimum, maximum and mean values for all the status. This is how we can do aggregation with group by to calculate values. If you don't want to pick a specific function, just to use the describe method like sto.describe to get the quick overview of your dataset. If you don't want to pick a specific function, just use describe. It automatically runs the most important aggregation functions for you and presents them in a neat table. And if I want for this single column, I can do it. I don't have to write each function, just use the describe to get the values for all of the functions with as little code as possible. So that is how we do it. So in summary, today we used the big 5 aggregation functions, then we learned statistical and distribution functions, then the aggregation method in which we can use many functions at once, and finally group by a method so that we can have the aggregation region wise or for a specific group. That was all about it. See you in the next chapter.